Imbibers, welcome back to today's session again. So children, as you all know, we are going on with the sexual reproduction in flowering plants and we have completed few topics of that particular chapter. Yesterday we have discussed about the stamen, the parts of the stamen, and we have also learned about the microsporogenesis. Yes, so today we are here with the another topic of the sexual reproduction in flowering plants, which is the pistil, microsporangium, and of course the embryo sac. You know, since we have already discussed about the male reproductive system, we are going to discuss about the female reproductive part of the plants. Yes, I hope children, before coming to the session on the Embibe app, you might have attempted your pre-class activities and the post-class activity. This is one of the most amazing features of the Embibe app, where you can attempt before coming to the session some activities and you know what is we going to discuss in the class, and after the session gets over, we can always attempt the post-class activity to know whether we have understood the chapter or not. Okay, so children, please join us on the Embibe app. Register for the classes for these amazing experience. So here I am. My name is Anam and be your botany expert. We'll be discussing all the amazing topics related to botany. And children, just like today, we're going to discuss the another topic of the sexual reproduction in flowering plants. So before that, let's start the discussion and know what we have already gone through and what we're going to basically discuss in the coming sessions. Talking about children, the topics which have been already covered and the today's topic and the topics which will be covered in the coming session are these. So we have covered the introduction towards the sexual reproduction in flowering plants, and we have also covered the flower, of course the part which are reproductive parts of the flower, and we have also discussed the accessory parts of the flower. Yes, and we have also covered the stamen, microsporangium, and are yet to discuss about the structure of the pollen grain. Yes, the next session would be about the structure of the pollen grain. We have this whole session totally dedicated, and there we are going to discuss about the structure of the pollen grain. Talking more about this chapter, in the subsequent session, we are going to discuss about the pollination, we are going to discuss about the outbreeding devices, we can also discuss about the pollen-pistil interaction, the seed formation, apomixis, and of course the post-fertilization event. Children, this particular topic is important for your board examination point of view, okay, and if in the subsequent years you wanted to attend for the NEET examination, this is also have a very good weightage in your NEET examination. Not talking about NEET, discussing only about your board examination. Children, from your board point of view, a lot of things have been already removed by the CBSE from your NCERT, but this chapter still exists, yet it has a very important significance. It has very significant chapter of your syllabus, okay, and yet it is very conceptual also. I would not deny that fact that the sexual reproduction in flowering plants is very conceptual, but it is not that hard that you cannot remember. Okay, so children, we are here to make it easy as much as possible. Let's see what we are going to discuss in today's lecture. Today's lecture is all about the pistil, megasporangium. We are going to discuss about how the megasporogenesis takes place and how the whole embryo formation is taking place. Okay, this chapter is totally, or this session is totally related to the megasporangium. So starting at today's chapter, you know children, while talking about the today chapter, so children, you know the certain saffron strands, if you remember, the saffron strands are very expensive. Yes or no? Because you know that saffron strands are nothing but those filaments. There's a part thread like structure, they're the parts of the stigma Those are the saffron strands, and you know that's absolutely expensive, and we use those saffron strand as in spices addition to our foods, etc. It gives a nice fragrance and nice flavor. Those are what? Those are just the part of the stigma. Yes, they are the part of the stigma only. So today we are going to discuss about those parts of the megaspore only. So talking about more about the megasporangium or the megaspores, you know the pistil. Since we have already discussed about the parts or the reproductive part or the female reproductive part of the flowering plants, we know that there is a pistil, which is the female reproductive part, which is further divided into stigma. Yes, there is a stigma, there is a style, and there is an ovary. Okay, the whole pistil is typically divided into stigma, style, and ovary. The female reproductive system of the plant or the female reproductive unit of the flower is called the pistil, and also you can call it as carpel. Okay, so let's see what are the various parts of the pistil we have. We have, yes, this is what I said, that the pistil is further divided into stigma, style, and the ovary. Yes, there is a stigma, which is this part, there is a style, which is long cylindrical part, and this part is the ovary. As you can see, children, there are locules inside the ovary, which is what you call, there is a locules inside these ovary, which are called what? Ovules. This whole part is your ovary, this is your style, and this is your stigma. So your pistil is further divided into stigma, style, and ovary. The locules are located inside the ovary, inside the ovarian cavity. This is your cavity, there is a locules inside it, those are called the ovules. Okay, this is very basic, and you know, children, when we have already discussed about the male and the reproductive unit of the flowering plants. Talking more in detail about this, we are going to talk about the megasporangium. Yes, this is the most important part. As you can see, children, just it appears like your lemon only. Don't you think? If we cut the cross section, this appears like, this is not lemon. I am just saying that it appears like a lemon only. Talking about the megasporangium. Mega stands for the female, sporangium, of course, there is a microsporangium for the male, there is a megasporangium for the female. Okay, talking about the megasporangium, children, they are commonly called ovules arising from the placenta, and the number of ovules may vary from 1 to many. So there is a megasporangium, there is what? There are ovules present inside it, and there could be one ovule and there could be many ovules. That can vary from plant to plant. Okay, so megasporangium, which is commonly have those ovules inside it, and those ovules will vary from 1 to many. Next, children, talking about the structure of this particular ovule. If we talk about the structure of the ovule, there is a funicle, there is a hilum, there are integuments, there are nucellus, micropyle, chrysalis, embryo sac, or the female gametophyte. If you basically clearly see the structure or the parts which are present in the megasporangium, these are the funicle, hilum. What is hilum, children? The hilum is the junction between the ovule and the funicle. If you clearly see this, children, I am going to just elaborate it for you so that you have a very clear depiction of everything. This is your ovule, and this is everything present inside the ovule. If you clearly see, children, there is funicle, there is a hilum, there is a nucellus, there is a micropylar end, there is a antipodal end. So children, this is integuments. The layer of the ovules are called integuments. The layer of the ovules are called integuments. There are inner layer which are called inner integuments. There are outer integuments which are present on the outside. So there is a layer of, I would say, there is a layer outside the ovules, 1, 2, 3. So there is inner integuments and there is outer integuments. Yes, there is a micropylar end and there is a chrysalis end. Okay. So on the micropylar end there is a 2 synergids present and there is this egg. Then at the center there is a polar nuclei, and of course on the chrysalis end there is antipodal cells. As you can see, children, this is a whole clear depiction of the inside of the ovule, how exactly everything is being clearly structurally being organized. So children, how this basically formation is taking place, that is what we are going to study in the megasporogenesis. But right now, just giving you a brief idea about this is how your ovule inside looks like. Okay, these are your egg cell, which eventually the male gamete will fertilize with the egg cell and will create an embryo. Then there is a polar nuclei. You know, this is the most important feature of the sexual reproduction of flowering plant is that they undergo the double fertilization. So the double fertilization is possible because the ovules have this particular egg cell, and these are the polar nuclei. Of course, we are going to discuss that also in detail, but just now giving you a brief introduction about it. Okay, so these are antibodal ends. There is a polar nuclei, inner and outer end. There is a funicle, of course, their his side, and there is a micropilar end. There is a chalazial end, and of course, embryo sac or the female gametophyte. Clear? This is the whole structure of the ovule. Clear? Moving forward with the more discussion about this, children. Next we have, if you could see this, giving a more clear idea about everything, children. If you see the structure of the ovule, this is your micropilar end. Just now that is what I told you. This is your chalazial end. The chalazial end has the antipodal cells. This is what I told you here in the previous slide also, that this is your chalazial end which has antipodal cells, and this is your micropilar region, and that stick like structure, that is your funicle. That is what is your funicle. If you could see clearly, if you have a better idea, because since it's a 3D structure, if you could see this short like structure basically representing the funicle, but since this diagram is more clear, as you can see, there is this egg cell, there is a polar nuclei, and there is outer integuments and there is inner integuments. Okay, and there is a placenta present. You know that placenta, it is basically attaching it to the megasporangium. Clear, children? So this is the structure of the ovule. Ovule has antipodal cells, the ovule have synergids, the ovule have egg cell, the ovule have central or the polar nuclei. The polar nuclei also together called as a central cell. We can also call this as a central cell. A central cell has two polar nuclei. A central cell has two polar nuclei. Okay. So this is the structure of body. How this is basically formed, that these are 3 cells, 3 cells, 3 cells, 7 cell, and there is a 8 nucleate stage. This is what is the most important concept of this particular, which we are going to discuss today only when we were discussing about the megasporogenesis. You will get to know how this ovule has these 3 cells, antipodal cells, these 2 synergid cells and 1 egg cell, and this central cell having 2 nuclei. Okay, so right now this is all about the structure of the ovule. Okay, I hope this is clear. Moving forward with the more elaborative form of the megaspore, let's see what we have next. Talking more about the megaspore, children, we have to discuss about the megasporogenesis. This is all the most, you know that the pistil has stigma style ovary, you know ovary has ovules, everything, but yet downs the most important part of the megasporogenesis. Your stigma, children, is nothing but a landing platform for the male gametophyte. Your stigma is absolutely sticky in nature. The style helps in the pollen tube formation. It helps the male gamete reaches to the female gamete. Okay, so landing platform is the stigma. The style is basically helping in the pollen tube formation, and then by the time pollen tube is formed, the male gamete reaches to the female gamete. What is most important about the megasporogenesis or the megaspore is that how they attain this 7-celled and 8-nucleated stage, because this is always the discussion, this is always a question that how this division is taking place, that this 7 cells and 8 nucleus is being formed. So children, this is what we are going to understand in this, which is the megasporogenesis. Talking about the megasporogenesis, children, the formation of megaspore. What is a megaspore? Your ovule. Okay, your ovule, which could be your haploid in nature through the megaspore mother cell. Yesterday, what was that? Yesterday, when we were talking about the anther, when we were talking about the stamen, it has the microspore mother cell. Yes, and today, since we are creating a megaspore, we have what? Megaspore mother cell, MMC. Okay, the formation of the megaspore from the megaspore mother cell is through the reductional division. You know, the sexual characteristics, the sexual parts undergo only the reductional division, which is the meiosis. This is what you have learned already in the 11th standard. So, the megaspore mother cell undergo the process of meiosis and give rise to a megaspore. Okay, 4 haploid megaspores are formed. One remains functional, the other 3 degenerate. So, if you see children, this megaspore mother cell, what would be the ploidy of the megaspore mother cell? It has to be 2n. Yes, there is a 2n ploidy of the megaspore mother cell. This is the ovule and this is the micropyle. Just leave it everything, just discuss. This particular megaspore mother cell will undergo division of the meiosis and will form 4 what? 4 functional, they will form, one remains the functional, another 3 dendrite, 4 haploid megaspores. These are 4 haploid, N. These are 4 haploid megaspore formed by the megasporogenesis, and when the megaspore mother cell undergo the process of meiosis. Out of this 3 which are present towards the micropylar region, they completely degenerate and only 1 survive. Okay, and 3 megaspore will degenerate during the process of maturation and only 1 will survive, and the 1 will only undergo further mitotic division and will create your 7-celled and 8-nucleated stage. Okay, right now what was more important is that the megaspore mother cell is responsible for forming the female gamete or the megaspore. The megaspore mother ploidy is the 2n, which will undergo the process of meiosis and will create 4 haploid cells, and among the 4 haploid cells, 1 will degenerate, 1 will stay and the 3 will degenerate. The degeneration of 3 haploid megaspores will basically takes place and only 1 will survive, and this 1 will eventually undergo the process of division and will create a 7-celled and 8-nucleated stage. I hope this is clear till now. Yes, it was very easy. It is not that difficult. It is just that you need to put some sort of concept to it, some sort of brain to it. It is absolutely easy to understand that how this megasporogenesis is basically taking place. Yes, it is more, I would say rather more complex than the microspore formation. Yes, it is little bit more complex than the microspore formation, because here the 7-celled and 8-nucleated stage will be formed. Moving forward, saying let's see what happens more in the megasporogenesis. Talking about children, as you can see, this is how the 3 haploid cells are being formed. So children, what is the significance of the meiosis? What do you think? Why mitosis is not taking place? Yes, I know the mitosis is an equational division, it takes place in the somatic cells, but what is the significance of the meiosis? The significance of the meiosis in the megasporogenesis is nothing, children, but to maintain the ploidy of the gametes. You know, the one gamete, the male gamete has to be haploid, the female gamete has to be diploid, and both the gametes will fuse to create a diploid cell, which would be creating a new structure or a new plant. So, maintain the ploidy, the megasporogenesis is also responsible for, the megasporogenesis is basically undergoing the process of meiosis. Clear? To maintain the ploidy of the gamete. This is just a simple question. This is how, children, when the megaspore divides, this is how 4 nucleus are basically formed, 4 haploid megaspores are being formed. Clear? Talking more about the megasporogenesis, if you see, children, the next we have one by one, we will see exactly how this is being done. Can you see this, children? This animation is absolutely perfect, giving you a clear idea how the 7-cell nucleated stage is being formed. Okay, talking one by one each and every point about each and every point, let's see what we have. The functional megaspore, only which was one was basically remaining, na 3 megaspore degenerated, no? Only one was left. Yes, this one megaspore is called functional megaspore. Okay, the functional megaspore will finally develop into a female gametophyte. Okay, monosporic development, it means embryo sac development from a single megaspore. What is a monosporic development? A monosporic development is the development when the embryo sac is developing from the single megaspore. This is what you call monosporic development. Okay, the functional megaspore, children, divides mitotically to form 2 nucleated embryo sac. So now the division is been already started in that functional megaspore. So the functional megaspore, when it starts dividing, it forms very first a 2 nucleated embryo sac. The first mitotic division, listen carefully, this is mitotic division. The division which is taking place inside the megaspore is a mitotic division. It is not meiosis, no, because it is already taking place inside the female gametophyte. So it has to be what? Mitotic. So after the first mitotic division in the functional megaspore, 2 nucleated stage will be formed. Then continuous 2 more division, mitotic nuclear division will create 4 nucleated stage, and later on 8 nucleate on the embryo sac will be formed. So continuously the functional megaspore will keep on dividing, will create 2 nucleated stage, then after that 4 nucleated stage, and there's 4 nucleated stage, after that 8 nucleated stage will be formed. Okay, mitotic divisions are strictly free nuclear, with the each division daughter nuclei moves to the opposite poles. Yes, when the microspore is when the megaspore is continuously dividing, the functional megaspore is being continuously undergoing the process of mitosis. Every time there is a nuclear division, there is a free nuclear division, it will move to the opposite poles. Okay, then after the 8 nucleate stage, the cell wall will appear. At maturity, a 7-celled and 8 nucleate embryo sac will be formed. At maturity, 7-celled and 8 nucleate stage will be formed at the maturity. The one functional megaspore will divide, form 2 nucleated stage. 2 nucleated stage, then 4 nucleated stage. 4 nucleated stage, then 8 nucleated stage. After the 8 free nuclear division has already taken place, each and every particular nuclei which move towards the opposite poles and will have the cell wall around them. We will start having cell wall around them, and in turn will having this 8 nucleus and 7-cell stage. So how this is being divided? As you can see, there are 3 antipodal cells, 3 nucleus, 1, 2, 3. 2 will be at the center, which is called polar nuclei, and the cell in which the polar nuclei are present are called central cell. Then there are 2 synergids, and there is 1 special embryo sac, and you can also called as egg, which is of course the fertilization will be taking place through that also, and there will be layer of integuments around it. Just now in the previous slides we have learned about the structure of the ovule, and this is how your ovule will generate. Okay, 1 nucleate stage. First of all, the megaspore mother cell will divide through meiosis, and 4 haploid megaspore will be formed. 3 megaspore will degenerate and only 1 will survive. 1 megaspore, which is a female gametophyte, will continuously undergo the mitotic division, and first of all it will create 2 nucleated stage, then from 2 nucleated stage there will be 4 nucleated stage, and after the 4 nucleated stage there will be 8 nucleated stage, and each nuclei will move towards the opposite poles, and as soon as they move towards the opposite poles, they start developing a cell wall around it. Okay, and this is how the antipodal cell, synergid cell, your egg cell and your central cell will be formed, and this stage is the stage which is called the 7-celled. Why 7-celled? 1 cell, 2 cell, 3 cell, 4, 5, 6, and this is a whole single cell which have 2 nuclei. The polar nuclei has 2 nuclei. The central cell will have 2 nuclei called polar nuclei, but is considered as 1 cell only. So this is what is 7-celled 8 nucleate stage. Is it clear? I really hope this is clear that this is 7-celled 8 nucleated stage. Okay, and this is how the megasporogenesis will take place. Clear? Talking more about this, children, we have this is what you called 7-celled 8 nucleate stage. There are antipodal cells, there is a polar nuclei, there is a central cell, there is an egg cell, there is 2 synergids, there is a filiform apparatus also. What is the function of filiform apparatus in the embryo sac? The function of the filiform apparatus is to guide, it's a guide. You know that if you go to some historical monument, if you go historical places, there is a guide which is basically telling everything which has happened way back. Yes, this is filiform apparatus over here. The filiform apparatus guides the male gamete to go through the micropylar region and fuse with the egg cell. So this is what it is, the embryo sac. This is the structure of your embryo sac. Clear? Clear? I hope this is clear. The 7-celled and 8 nucleated stage, which is absolutely important from your examination point of view. Next we have egg apparatus. What is an egg apparatus? You know the egg cell, antipodal cells, polar nuclei, ovule, egg cells. Okay children, it consists of 1 egg cells and your 2 synergids. This 1 egg cells and the 2 synergid cells which we have already discussed, it bears a prominent structure called filiform apparatus. What does the filiform apparatus do? Just now we have discussed about it. The filiform apparatus guides the path of the pollen tube to the egg. Yes, this is what we have discussed about it. The filiform apparatus act as a guide, guiding the male gametes towards the egg cell. Okay, function, it is helping in obtaining a nourishment from the nucellus and act as a shock absorber. So the major function of the whole egg apparatus is to absorb any shock and also provide nourishment to the egg cells from the nucellus. Okay, what is nucellus? If you basically all the integuments together is called nucellus only. Okay, providing nourishment to the egg cell. Next important thing which we have is the polar nuclei. So what is the polar nuclei, children? You know, I have already told you that the 2 polar nuclei form a central cell. So before fertilization, the nucleus of the central cell become fused and becomes a diploid secondary nucleus. Why diploid? There are 2 nucleus present in the central cells. So if they fuse, they become diploid secondary nucleus. So secondary nucleus take part in the triple fusion and leads to the formation of primary endosperm mother cell. This is have its own detailed discussion during the double fertilization, but right now giving you an introduction only that this polar nuclei, which is a part of the central cell, which eventually create and convert into a triploid fusion will takes place and it will form PEN, primary endosperm mother cell. Okay, and after the division, nutritive structure called endosperm which provides nutrients to the developing embryo. So this secondary nucleus which will eventually develop into through the triple fusion will eventually give nourishment to the embryo, because when the male gametes is going to fuse with the egg cell, they'll convert into an embryo, and the nourishment of the embryo is the responsibility of the polar nuclei or the central cell. Clear? So this is about the few features about the polar nuclei. Okay, moving forward, discussing about more, children. Next we have antipodal cells. So what does the function of antipodal cells are? As you know, present at the chalazial end, 3 cells which are present at the chalazial end, that is called the antipodal cells, and they are absolutely rich in protein, lipid, starch, ascorbic acid, and the function of this particular antipodal cells is to provide nourishment, growth of the developing embryo. So everything which is present inside the embryo is not a waste. So even these antipodal cells are also providing nourishment to the embryo sac. After the fertilization, after the male gamete fuses with the embryo, after the male gamete fuses with the egg cells, creates an embryo, also the nourishment is given by the antipodal cells, and they also have this growth hormone for the developing embryo. Okay, so everything inside the megasporangium is of course absolutely important. Okay, moving forward children, next we have a question for you, because we have discussed so much that what is the correct arrangement of the nuclei in normal embryo sac? What do you think was the correct arrangement? What is the correct arrangement? What is the correct arrangement? Yes, the correct arrangement of the nuclei in a normal embryo sac is 3 plus 2 plus 3. Yes or no? 3 antipodal cells, 2 polar nuclei and 3 egg cell plus synergids cell. This is what we have studied, 7-celled 8 nucleate stage. Egg apparatus consists of 2 structures. Identify them. What is your egg apparatus consist of? Structures which are present in the egg apparatus. Just now we have discussed about it. Your egg cells. So children, if you join us on the Embibe app, you will be able to answer directly using the mouse or the keypad you have. Okay, I know this is not possible on YouTube, but you can, if you register through the Embibe classes, Embibe app, you can directly opt for this option. You can use your cursor for answering this. Okay. So children, your egg apparatus has 2 structures called one egg cell and 2 synergids. This is what we have studied. The 2 synergids are there and this one egg cell is there present in the egg apparatus. Okay. The next question. Connect the bubble with the correct ploidy of the different cell of the embryo sac. Come on, quickly tell us the correct ploidy of the embryo sac. The correct ploidy of the embryo sac. The correct ploidy of the embryo sac. Children, you know what is the correct ploidy of the embryo sac? The egg cell is haploid, the antipodal cells are haploid, the synergids are absolutely haploid, because each and every have the single nuclei only. The mature female gametophyte is, this is so easy. Just now we have discussed about it. This is so easy. Mature female gametophyte, how many cells are present in it? It is 7-celled 8 nucleate. Absolutely easy. You know this is what megasporogenesis is all about. When the 3 megaspore, I'm just confusing because we have already discussed about the microspore. The 3 megaspore which are haploid degenerate and one will eventually develop into 7-celled and 8 nucleated stage. So children, which part of the gynoecium determines the compatible mature of the pollen? So which part is define the compatibility? Which part defines the compatibility of the pollen grain? Because it will not let the pollen form the pollen tube if it's not compatible. Of course children, it has to be the pistil which is compatible with the pollen grain. The stigma, the style and ovary, if the pollen is not compatible, it will not lead to the fusion of the gametes. Next question. In a flower, if the megaspore mother cells form megaspores without undergoing meiosis, and which one of the megaspore develops into the embryo if the nuclei would be? Yes, diploid. It will be completely diploid. If a megaspore mother cell undergo meiosis to form 4 haploid megaspore, 3 will degenerate and 1 develops into an embryo sac. Without meiosis, the diploid megaspore will form diploid embryo sac and its large oval sac. Of course, it has to be. The diploid megaspore mother cell will convert into a diploid embryo sac only. Yes, out of 4 megaspore during the megasporogenesis, the 3 remain functional and 1 degenerate. Do you think this is true or this is false? This is true or this is false? This is absolutely false. Only 1 survive and 3 degenerates. So children, here we comes to the end of our session, which is the pistil, megasporangium, megasporogenesis. We have learned about that the pistil or the carpel is divided into stigma, style and the ovary. Okay, there is a megasporogenesis which takes place. A megaspore has a megaspore mother cell which is diploid in nature, undergo the process of meiosis, forms the megaspore, which is one functional megaspore which eventually mitotically divide to form 7-celled and 8 nucleate stage. A mature embryo sac will have 7 cells and 8 nucleate stage, and at the micropylar end the egg apparatus is present consisting of 2 synergids and 1 egg cell, and at the chelazal end there are 3 antipodal cells, and at the center there is a center cell having polar nuclei. Clear? So this is all we have studied. Children, before we end this class, I want to tell you that you can join us on the Embibe app. Register for the session. This is all the sessions are in the sequence, and next I am going to talk about the structure of the pollen grain in detail. Okay, this is absolutely important for your board examination. This whole chapter is important for your board examination. So please try to join us on the Embibe app. I'll give you a brief introduction to this. Yes, before you go, you know that since both male and female gamete are non-motile, how do they come to the together for the fertilization? That is also a question, that how basically it is possible to let the fusion of both male and female gametophyte. This is your Embibe app, children, which you can log in through your email ID or your phone number. If you land on this, as you can see, this is 12th standard. Click on the home page button. As you press on the Embibe live classes, you will end on this. This is me right now taking your classes, children. You can join us on the Embibe app always. These are the Embibe classes for the next 7 days, and if you have missed any session, you can always watch the session whenever you want. So you can learn also through the Embibe app using different books, different videos. You can practice different questions from different chapters, and you can always test yourself. You can see whatever you have achieved. Your progress will be also seen. And this is the another Embibe amazing app, which is the Lens app. What you have to do, you just have to download it, scan the text, it will highlight everything in 3D, and it will highlight everything and give you a great visual understanding or visual learning with the 3D objects. So children, I would request you to join us on the Embibe app. Until then, we'll meet again with another lecture of this particular chapter, which is sexual reproduction in flowering plants. Until then, please take care, keep imbibing. Bye bye.
Keep imbibing. We believe in you.